Okay, the next problem is number 6. It says you're hiking along a river and you notice a tree on the other side of the river at an angle of 30 degrees. And then you hike further, 100 feet further, and you notice that the tree's at a 45-degree angle now. The question is, how wide is the river? I'll call that x right here. Okay, so you know these angles then, if as well. If you take 180 minus 45, you'll get, this is 135, not drawn very well. This would be 15, this would be 30. And then we can use it to find this leg right here, which in black, because I'll use the law of sines to do that. So I'll do the sine of 15 degrees over its opposite side, 100, equals the sine of 30 degrees over its opposite side, which I'll call that y for right now. I'll solve for y, and I'll keep that in my calculator, because now I've got a right triangle right here, which I'll highlight in green, that I can use to find the height across the river, the distance across the river. The 45-degree angle goes here. So it'd be opposite over hypotenuse. So it'd be sine of 45 degrees equals opposite x over the hypotenuse 193.19 value that I have in my calculator. Multiply by that by both sides, and you get about 136.6. Be careful with rounding, might need to round more than that. Okay, the next problem gives us the volume of air contained in the lungs, modeled by this equation where T is in minutes and V is volume in cubic centimeters. All right, so the maximum possible air volume is, if you think about it, sine fluctuates between -1 and 1. So this number is going to fluctuate between -1 and 1. So the highest it can be would be if it's a 1, in which case you'd add these together, and you'd get 1218. The lowest it can get for the next question would be if it's -1, in which case when you plug in -1 here, you get 428. So how many breaths does the athlete take per minute now? If you think about it, what period is the time for one revolution, which in this case is one breath. But if we switch this, we get actually the number of breaths per time for 1 minute. So when you switch this, the time and the breath switch, right? So period is time over one breath, and frequency, which is what this is breaths over time, which in this case is the number of breaths in 1 minute. So the reciprocal of the period gives you the frequency, which is what they're asking for here. So my period is 2 pi over b, which b is 41 pi. The pi's cancel and you get 2 over 41. And if you reciprocate that, you get 41 over 2, which is the frequency that they want here, 41 divided by 2. Okay, the next problem says find a formula for this function here. Now, I'm going to use cosine instead of sine. It doesn't matter, but I notice that cosine typically goes like this. So I know that if I were to reflect the cosine, over this line, it would, by putting a negative sign in front, it would be the blue function. So, basically I'm imagining that I'm going to start off with a cosine function, which is going to be like this. So it's going to go like this, and I'm going to then, more like this. But I'm going to then shift this. I'm going to reflect this actually over by making it negative cosine of x, so that I make it this red function right here. And then I'm also going to shift it up now 4 units so that the middle line is right here. So I'm going to move it up 4 units like that, and that's my answer. Okay, the next problem gives us a function here, and it's got some variables z and w in it, but those are just, imagine those as numbers. Another variables, technically we don't know what they are, but they're constants. That's what it says here. So the question is, what's the furthest distance the mass is from the equilibrium point? So imagine the biggest cosine gets is 1. So the biggest cosine get here is 1, in which case the maximum amplitude would be 6z centimeters, where we don't know what z is yet. And then the other thing is how many oscillations are completed in 1 second. Keep in mind, period is the time it takes to do a certain number of oscillations, or one oscillation typically. So the frequency would be the reciprocal of that. So what we're looking for is the reciprocal of the period. So the period is 2 pi over b, which is 2 pi over 8 pi w. The pi's cancel. 2 goes into 8 4 times, so it's really 1 over 4 w. We want to flip that to be 4 omega or 4 w, whatever. That's our answer for the second one. Okay, the last problem then, the answer should be sine of pi over 4 t plus 15. And if you want to know how I got that, I set period equal to 8 because it told me that period was 8. and that's equal to 2 pi over b. So if you solve for b, that's how you get the pi over 4. And then it needs to be shifted up 15 units because your sine function needs to look like this to represent you're going down and you go back up to the maximum. We'll go over this one more in class. This is a tough problem. If you have questions, you can ask me this in class. We'll go over it more. But the answer ends up being sine of